Cool. Welcome to CocoaHeads 198. Made it 198 times. 2 more to a big round date. In the spirit of reconciliation, Melbourne CocoaHeads acknowledges the traditional custodians of country throughout Australia and their connections to land, sea, and community. We pay our respect to their elders past and present and extend that respect to all Aboriginal and Torres Strait Islander peoples today. Tonight we have 2 talks from Andrew. If you thought the speed of writing code was your problem, you have bigger problems, 100% that. And Marcelo talking about orchestration with the Swift Temporal SDK. Sounds interesting. Code of conduct. Our community is dedicated to providing an exclusive environment for everyone, regardless of gender, identity, expression, age, sexual orientation, disability, and all that stuff. You know that. Be nice. If you have any questions, please raise your hand after the talk, not during the presentation. Also, feel free to post the questions in our Slack, and we're gonna do our best to answer them. Okay, time for sponsors. Our gold sponsor, Mantel Group, please applaud. Thanks, Mantel Group, for hosting us and for being the gold sponsor. And our silver sponsor is RE Group. Round of applause. Thanks, RE. Before we go to the talks, let's remind everyone about our upcoming social events. That is Coding Night next Wednesday. That is happening here at Mantel office. And CocoaHeads Social Night, that will be a different date and a different location this time. So pay attention. It's going to happen on Wednesday. And it's going to happen in the Precinct Hotel before the Dev World. DevX or Dev World? Dev World.
Don't listen to Tubbs, Dev World.
Dev World it is. Okay, so we have other social group, Sydney CocoaHeads, GGG, Melbourne, and the CocoaHeads Social. You can scan this one. You can find us on melbournecocoaheads.com, on Slack, and on Mastodon, Melbourne at cocoaheads.social. Is anyone using Mastodon at all? Nice. Okay, we have a few useful channels in Slack. If you want to join them, we're always looking for volunteers and speakers. The job's been quiet for some time, so if you know anyone who's hiring, just post there. And before we begin, I'm going to invite Andrew to the stage, and I'm just going to spice things up a bit. I'm going to ask you a question.
Go for it.
So, well, it's a trap. Yes, it is.
I love traps.
Nice. So, have you ever been pranked at work? And did you enjoy it?
Yes. Yes and yes.
Okay.
Do you want me to tell a story?
Yes,
or-
tell
okay.
a story.
Okay, well, I'll probably need the microphone for that.
100%. Here you go.
So I actually have a picture of this somewhere, but I was working for a small startup. For some reason, one morning, they decided that what they would do is all have fake mustaches. So I just walked into the office, this is back in the before times, so they were all facing their desks.
Is that your notes again?
No, I didn't mess up this time, Bok. One time is enough for messing up. So they were all facing their desks working, so I didn't see anything. And I got halfway down the corridor between all the desks, and they just all turned around to look at me at the same time with these big, stupid, fake mustaches on. I just laughed for about 5 minutes straight, and then asked if I could wear one.
Hey, before you start, give me a otherwise I have to do it manually.
Cool.
Go for it.
Okay, so I'm probably not going to be my big bubbly self because I was sick last week and I am really struggling with energy. I was just saying to Bok earlier, I was sat in the foyer before this. Do Australians use the term foyer? Foyer, okay, cool, we'll say foyer. I was sat in the foyer downstairs and I actually fell asleep and I woke myself up by snoring. So probably not going to be the usual energy levels this evening. And also, this is the first time I've done this talk, so I really would appreciate any and all feedback you can give me for this. I'm going to be doing it at NDC Oslo in September, so this is a great practice run for me. If it makes sense to you, let me know. If it doesn't, let me know. If there's bits that you think didn't hang together, just any and all feedback, and I will try and take on board as much as possible. So yeah, this is going to be about AI. Again, I'm sorry, but it's going to be about the fact that there's a lot of issues with AI to do with the productivity gains that we expect to get from it. I am not an AI maximalist, but I'm also not an AI pessimist. If you saw the presentation I gave a couple of months ago, you'll know that I've been on my own journey with this, and I've been kind of feeling out what it means for me. And something that happened for me is I'm a nerd. I got into software development because I love writing code. And I loved, after I did my presentation last time, Bok talked about the stuff that he did and all of the stuff that he's been building. And I love building stuff as well. I've had so many weekend projects. Not only am I a software engineer, I love doing DIY. I've got chickens at home. I'm a finance nerd. I track everything. And I'm also a smart home nerd. So I always am building something somewhere because I love doing it. But historically, I found that what happened pre-AI was that I was limited by my ability to code the things that I wanted. So I'd have all of these ideas, all these things I wanted to make, but when it got to actually coding them, I just didn't have enough time on the weekends, especially as a father of 2 kids, to build everything that I had the idea to make. And so what would happen is I would have to start prioritizing and things would drop off the to-do list. And what really excited me about AI coding was the fact that suddenly that wasn't the bottleneck anymore. Every dumb, stupid idea I had, I could code. I have made so many things, it is unreal. The ability for me to have an idea and then Friday night think I want to build this thing, and Sunday afternoon I've got something that works. And it's not production. It's not something that I'm going to put in front of customers. I do AI in healthcare. I would not do this in my day job, but for something for me to use, for something that helps me make decisions, it's been absolutely incredible. So to give you some real concrete examples, we've got solar panels at home, and I wanted to work out, the battery rebates disappeared in Victoria. I wanted to work out if it was the right choice for us to get a battery at home. So I was like, okay, well, what I'll do, because I'm a nerd, I could just, read what they say and find out what battery is the right choice for me. That's not who I am. I'm autistic, so I don't like that. So what I did instead was downloaded for the past 3 years, every 5 minutes, the snapshot of what I was feeding into the grid and what my solar panels were generating, so that I could run simulations to work out what would have happened if I'd have had certain sizes of batteries. 2 years ago, this would have been an idea I had, and I'd have spent 2 weeks building this thing, testing it, debugging it. I gave a prompt to my OpenClaw, and within an hour, I had something that worked. Would I ship that as a product to end customers? No. Would I use it? Yes. And it allowed me to make the decision. I have built so much stuff. I have gained so much personal productivity from AI coding at home. And I was talking to a friend of mine that I work with about this. And he's not technical. He's an incredibly smart human being. He comes from a physiotherapy background. And his first question was, so why can't we do this at work? Why does it feel like the productivity gains you get from doing this stuff on your weekend projects, why does that not translate into work? Why can we not have an idea and an hour later have a fully working production-ready system? The answer to this is that the bottleneck at work is not coding. AI coding is amazing. Claude Code is great. Codex is almost as good. Copilot can sniff glue. But the bottleneck at work is not coding. I've used the term bottleneck a few times. Has anybody heard of the theory of constraints? Yeah, a few hands going up. So the theory of constraints was written by a gentleman called Eli Goldratt in the 1970s. He put a book together called The Goal. Has anybody read The Goal? Yeah. It's an amazing book. It is a book written in the 1970s that has no right to be as valuable and true to the world of software development as it actually is. It is a book about physical factories and how you optimize the production flow through physical factories. And it applies to work, to our work, to software development in a way that you would not believe once you read it. There was a book that was paying homage to it, that was taking those ideas and kind of translating them more specifically to software development, called the Phoenix Project. Has anybody read the Phoenix Project? Of course. My advice to you, if you like the way that I'm about to talk about this stuff, and it kind of tickles your brain and resonates with you, I want you to read The Goal. I really, really do. But it's a hard read. It is a really hard read. It's a book from the 1970s, so it is a hard read. If this stuff resonates with you, read the Phoenix Project first, then read The Goal, if you like the Phoenix Project. The Phoenix Project was written by Gene Kim and I can't remember, somebody else. It's a really, really good book. It basically takes a narrative approach to talking about these topics. So it's a story, but it's a story that teaches you how this stuff applies. And I love it and hate it at the same time because I see myself in pretty much every single character for all their negative traits. So, theory of constraints in one slide is that every system has exactly one constraint. Whatever that is, it has one bottleneck. And the throughput of the entire system is determined by the throughput of that one constraint. So, what do I mean by constraint? What do I mean by bottleneck? Well, I mean this. Literally, it's called a bottleneck because it looks like the neck of a bottle. Like, that's why it's called bottleneck. But, you know, pretty much this is what a bottleneck is. If you've got a system, if you've got a flow, in this diagram I'm demonstrating ideas, concepts, pieces of work as dots, I'm demonstrating parts of the process, such as ideation, coding, and a working thing as these pipes. And I'm demonstrating how quickly that thing works on something by the width of that pipe. And so in this example here, we've got approximately 38 things in a minute coming in as ideas. I'm having 38 ideas a minute, but my coding can't match that. My coding can't keep up. So I'm only getting about 17 working things a minute out the other side of it, and I've got to kind of prioritize and drop things off. So the bottleneck in the system is coding. It's the thing that has the lowest throughput, and it doesn't matter how many ideas I have. I am limited, in this example, by my ability to code the thing. Does that make sense? Awesome. Okay, so the thing is that when you look at all the research, actually fingers on keyboard writing code is about 16% of writing of the time that we spend as engineers. 16%, 1/6. Terrible, isn't it? The good news is it went up. In 2024, it was 15%. So we're making progress. But all of that other 84% is everything else. And right now, AI coding doesn't help with the 84%. It only helps with the 16%. And so this is why when you introduce AI coding in an organization, you don't get the speed ups that you're expecting to see, and why it's not the same as when you're at home. So let's look at this. A typical organizational pipeline is much more complex than me sat in my office at home making something. You've got the creation of ideas, but then you've got to discover if they're actually good ideas to make in the first place. And then you've got to prioritize those ideas, and then you've got to make the code, then you've got to review the code, and then you've got to integrate it and QA it, and then you've got to deploy it, and then the users have to use it. So this is a much more complex system. And this is still a little bit of a toy example. Your organizational flow is probably still much more complex than that. So what do you think the bottleneck in this process is?
The code.
The code, yeah. It's pretty obviously the code. So if we were in an environment like this, where the bottleneck is the code, and really what we've got to do is we've got to prioritize what we're building because we can't get enough stuff through the bottleneck is the code. So what happened, if I magically introduce AI coding into this process and I 10x the throughput in the code bit, what's going to happen? It'll go somewhere else, correct. Any guesses where it'll go?
Based on that, review or discovery?
Review or discovery? Yeah? Anybody disagree with that? Should we find out? Let's run it. Ooh, where's my mouse? There we are. And let's speed it up a little bit. Discovery. So here we've got a system where it doesn't matter how quickly we can code, it doesn't matter how quickly we can prioritize, doesn't matter how quickly we can deploy it or CI it or QA it. It's completely irrelevant because we can't work out what the right thing to build next is. Does this feel like maybe your organization? Yeah, a few nods. This is a pretty common one. Another really common one is review. So you can produce all of this code, but you can't review it quickly enough to actually get the value to customers. And so again, it doesn't matter how fat the coding pipe is, you cannot get stuff through the pipe quickly enough. So by just applying AI to the coding, we basically took the thing that worked for our weekend toy projects and we applied it into the business environment. It works at home because at home coding was the constraint. I just have so many dumb shit ideas that wasn't the problem. Nobody was going to tell me no for my ideas other than my wife. So that wasn't the problem. The problem was I just couldn't type code fast enough to create these things. At work, that's not the problem. And again, if we fix discovery in this system, what's the bottleneck now? Review. So this is getting the idea that no matter what we do, there is always going to be a bottleneck. Now, what happens in this situation if I just double the resources in review? It unblocks the bottleneck. What happens if I double the resources in discovery? Absolutely nothing. But interestingly, and this is one of the things from theory of constraints, is that if you optimize the thing that isn't the bottleneck, the best case scenario is that nothing happens. The worst case scenario is that everything else breaks. And so actually applying theory of constraints and going, let's just double coding speed, let's 10x coding speed, makes things worse, not better. That's what theory of constraints tells us. So that's why we see this all the time, where we accelerate the coding, but the system itself doesn't get better. The system itself doesn't produce more things out of the other side. And as an example to show you of what I meant about how things can actually get worse if you optimize something that isn't the bottleneck, this is some research that GitHub Copilot did and combined with some stuff that Git Clear did and Dora. So coding speed, this is across the organizations that they looked at. Coding speed went up 55%. Code churn, which is the amount code is changed, doubled. So basically code that had already been written was changing more often. But interestingly, delivery throughput, which is the amount of code that meets production, went down. So we changed more things, we added more code, we changed existing code more, but we actually delivered less to customers. Not only that, but stability went down even more so. So pretty much what that's saying is you produce more code but ship less software. Produce more output but produce less outcomes for your users and your customers. A really interesting fact, that's a bit small there, I'll read it out. Experienced developers using AI actually took 19% longer performing the same task, but if you asked them, they felt it had been 20% quicker. So subjectively they felt they were quicker, objectively they were slower. Now, I don't want all of this to make you think that I'm sat here telling you that AI code is a problem. I have not personally written a single line of code in the past 6 months. AI has written every single line of code that I have produced. So I am not an AI naysayer. I'm also not an AI maximalist. I'm not an AI hype person. It just isn't the miracle that we wish it was, or frankly, the miracle that our bosses wish it was. You have to take it with a huge, monumental grain of salt. Because remember what I said, only 16% of our time is taken up by writing code. Faster code generation only optimizes that little bit of the process. So let's talk about where the constraints actually fit and sit in some examples of organizations. So one that's pretty common that I mentioned already is you don't know what to build. You've got all of this engineering capacity sat there. You just don't know what you should build. This is really, really common, especially in large enterprises where they're often the decision-making in large enterprises is risk-driven, not value-driven. So in a large enterprise, you have an idea, and somebody goes, well, what will go wrong if we do that thing? because the risk of something going wrong is much greater than the benefit of that thing going right. And so everything just kind of gets discounted because they don't want to take the risk of it going wrong. But this can also happen in larger companies. I've been a big advocate. Every single company I've worked in for the past decade, as an engineering manager or a director, I've pretty much said, stop hiring engineers and start hiring more product managers and UX people, which is a really weird thing for the person that hires the engineers to say. And it's because of this problem. Knowing what to build is incredibly important. And if you don't spend the right time in doing that, you end up with a whole bunch of other problems further down the line. And if you don't do that, you end up arriving at something sooner. And I've toned this down because this is an Oslo talk that I'm going to be delivering there, and they don't swear as much as Australians. If you read the blog post this is based on, that word started with an F. So that's basically the problem you're going to get. You're going to arrive, if you just code quicker, you're just going to arrive at that moment of, oh no, sooner. The next typical place where we find the bottleneck in organizations is everything after the code. So things like review, CI, QA. Does anybody feel like this is their organization? Yeah, a few hands going up. Yeah, so you've built, you've written the code, but before it actually gets in users' hands, somebody's got to review the PR, or somebody's got to do the testing, or somebody's got to make sure it goes through the pipeline correctly and everything works. This is a bottleneck that AI actually can make a lot worse. Most often what you see with AI coding is that the number of PRs increases, kind of expected. The complexity and the size of the PRs tend to double. Some organizations, interestingly, this is different. So I was talking to Culture Amp. Their PR size went down, which was really unusual. Most companies, the PR size goes up, which makes it harder to review. And what actually ends up happening is you end up in this situation where, Monday the PR is opened, and the person who wrote it, remember, didn't actually write it, prompted the AI to write it. They remember everything, of course they do. But, on Tuesday, when it's sat in review, they started coding something else. And then Thursday, the comments arrive, and, they look at it, and they think, oh, yeah, I'll get to that tomorrow. And then it gets to Friday, and it's like, I don't remember what I wrote. I don't remember how to fix it. And so you end up with PRs getting rubber stamped, as opposed to people actually reviewing the PR. I see this a lot where I was working with a company, and what they started doing AI coding, and so their delivery stability went down. So they said, okay, let's get humans to review PRs as a priority. Delivery stability went up a bit. Then they went, okay, let's get AI to review the PRs. And so they basically did all the coding with GPT, and then had Anthropic's models do a review of the code. So they removed humans from the review loop. Delivery stability went up, not down. Because the humans got bored, distracted, didn't care, just rubber stamped the PRs. AI doesn't get bored. AI doesn't get distracted because Slack just popped up a notification, or is feeling a bit hungry because it's almost lunchtime, or had their lunch and is getting the afternoon slump. So interestingly, they found that actually having AI do the code review made things better, not worse. The other thing that often happens is you end up with a deploy trust spiral, where you basically deploy something, it breaks, so you go, okay, well, let's batch all the changes together. And then you do a bigger release, and then you deploy less, and then you're kind of back where we were in the 90s when we did waterfall. Does anybody want to go back to the 90s and do waterfall?
Sometimes it feels like it would be easier.
Sometimes it does feel like it would be easier. Yeah, there's an interesting side of this, which we can get to in the QA. If nobody asks it, ask me about change fatigue, because change fatigue is real, and interestingly, this is actually a potential solution to it. Another problem we see is actually people's calendars being the load-bearing wall of the organization. And what do I mean by that? is sometimes getting something into production requires a human being to click a button. And that human being is so busy that you can't get their time to click the button. Sounds stupid, happens more often than you think. So, somebody pointing fingers around here right now. And so what happens if that person's in a meeting, or on holiday, or gets sick? It happens. So no amount of AI coding is going to increase the delivery of value to your customers if you've got to wait for somebody to click a button. And no amount of Copilot refactors the org chart, no matter what Microsoft tells you. So really what I'm talking about here is that the amount of code output is the wrong thing to be looking at. Measuring what we do as an organization by the number of lines of codes we write, we've always known this is a stupid idea. So why are we saying that AI gives us productivity gains by increasing the amount of code we can write? The same people that will tell you it's a bad idea to measure an individual engineer's productivity based on the lines of code will use that back again to say they've had increased productivity by producing more code. What we should actually be doing, and we've known this all along, my genuine belief is that AI is not making anything better or worse that wasn't good or bad about your organization before. Anything that was good about your organization, AI makes better. Anything that was bad about your organization, AI makes worse. If you're measuring lines of code and PRs and story points, you're going to look better, but you're not actually going to be delivering value. The things we should be measuring are the things we know we should always be measuring, which is cycle time. How long do things spend at various stages? How long do they wait before they get picked up? How often are we deploying to customers? And crucially, how much value are customers getting from the code we write? And when are they getting that value? Because just because something's merged into main doesn't mean we helped somebody do their job better. So, whatever is good about your organization, AI makes better. Whatever is bad, AI makes worse. The same queues exist, the same handoffs exist. If you just apply AI coding, all that you end up with is more PRs. You don't end up with better value. So my advice to you, if any of this resonates with you, what I would suggest you do is try and take a look at the entire pipeline of code delivery in your organization. Follow one feature from when it was first thought about as an idea, as a concept, to when it was actually in users' hands. Follow that through the whole process. Write down what happened to that idea. How long did it spend with each person, with each team? How long did it wait before it got to the next point of the process? Wherever the longest wait time is in that process is where your bottleneck is. And unless it's coding, which it probably won't be, AI coding isn't going to make that any better. There's a great thing that the agile kind of lean people talk about, which is stop starting, start finishing. And the basic concept of that is stop starting something new. Every time you start something new, you're adding a new thing into this pipeline. What we should be doing is looking at the bits of the process that are the bottleneck and start finishing the work that is in those bottlenecks. So if you remember nothing from this talk other than 4 words, those 4 words are stop starting, start finishing. If your bottleneck is code, AI is great, use it there. If it's not, find out where the bottleneck is and use AI there. If your bottleneck is in discovery, working out what to build, a great way to do that is using AI to take a lot of research together, synthesize it and create reports, looking at the logs of your system, how are people actually using your system, trying to find analysis over the support tickets. Just use AI for that research. Human in the loop makes the decision. AI helps make that quicker. If your bottleneck is in review, make your PR smaller, clearer, and safer. If your constraint is in CI, find those flaky tests and fix them. Doesn't this all sound like stuff we should be doing anyway? Yeah?
Yep.
AI doesn't make your system better. It makes the good things about it better, and it makes the bad things about it worse. So fix the bottleneck, wherever that is. It's not the keyboard, unless you're a home warrior making dumb shit on a weekend. Thank you. Questions?
Change fatigue.
Oh yeah, change fatigue. There you go. I'll answer that in a second.
One about sort of a long-standing methodology that a lot of people use, which is test-driven development. And one of the things I've seen recently is in review, people skip over the tests, and what's started to happen is probably more often than not, the code that's actually in production that the customers have got in their hands is handwritten or mostly handwritten. But then everyone's prompt is take my changes and write tests for them.
Yeah.
And then it doesn't get reviewed. Do we need to start actually thinking about actually, and it's sort of, it'd be a big change for a lot of organizations. Let's just get rid of all the unit tests. If all we're doing is here's my changes, make the unit tests work, well, good on. And if no one then reviews them, who cares? You know, actually write out the business constraints and ask the AI as part of your pipeline to actually go, does this code meet the following list of business requirements, rather than do the unit test run? Because from what I'm seeing more and more, I think people are just getting AI to write the unit tests, and then the people who do the reviews look at the code that's actually going into production, and then 4,000 lines of unit tests that have been written. Yeah, I don't care. So just move on with life. And is it again? It's not necessarily fixing a particular constraint, but it's sort of, it reduces the amount of code coming into review and then through the pipeline.
And the other benefit of that is, if you don't do that and you just have, if every new PR has 10 new set tests, how long until you've got 5,000 tests that have to run every single time? You're slowing those feedback loops. Yeah, you're right. So there's an interesting discussion around what is the source of truth of your code base. Is it the code? Is it the tests? Is it the documentation? I think an interesting angle on that question is, yes, all of those things are the source of truth. And the job that an AI is really good at is finding where those things disagree. And a really good starting point for moving from where you're talking about to where you're going with effectively spec-driven development and the business case side of things is to ask an AI to go, this is the spec that we think the code does. Does this actually align with what the code does? And getting to that point first before you change it. It's a bit like, trying to write tests for the code. It's like trying to write specs for the code. Because what you might find is you write the spec and you realize the code does something different. And then which thing is right?
Yeah. So one of the things I found is that if AI makes a mistake, it'll keep on making that mistake.
Yeah.
So you've got to have, like, if it goes wrong, you've got to have regression tests. So then when it makes exactly the same mistake next time, like, the tests will put it back on track. Because yes,
until it fixes the test.
Yeah. It has this habit of fixing the test because it thinks it's right.
Yeah. There's. Are you aware of what mutation testing is?
Yes.
So mutation testing and property-based testing are really great ways of testing your code base. They're just really annoying and time-consuming to do. Guess what AI doesn't do? Doesn't get bored. So writing a whole bunch of mutation tests, a whole bunch of property-based tests is actually something you can get AI to do. So one way to work around that is to actually incorporate property-based testing and mutation-based testing. I won't go into what that is in too much detail. If you want to know, if you don't know what it is and you want to know more about it, just ask me afterwards. We can talk about it. It's fun.
I feel like there's a constraint missing, which is budgetary.
Yeah.
So, like, yes, we could expand delivery, but you can expand delivery only to a certain kind of fall-off point. So with I feel like budgetary is like the thick pipe that sits on the outside of the rest of all of the expanding bottlenecks. And yeah, to me, looking through that, it's like we've rapidly expanded the bottleneck of coding. To me, just kind of devalues those that were operating the agents for coding in the organizational budget pipe.
Mm-hmm.
Yeah. So, yeah, that's me.
We're getting into some philosophical ideas here around like why have we been very lucky to be paid the ridiculously high salaries we've been paid as engineers? Because we're rare, because it's difficult to do our job. Those things might be changing. The leverage we thought we had, we probably won't have in 5 years. We're probably not going to have the cushy careers we thought we were going to have, which scares me a little bit. On to something happier. Shall I talk about change fatigue?
Yes.
Cool. Sure, one question there, and then I will cover change fatigue.
This is sort of going on from that last question. in
Yay.
that it was thought-provoking. So if we're trying to solve an earlier point in the pipeline and reduce that from being a bottleneck, would having people sort of be more involved in those earlier processes be beneficial?
100%. How much time do I have?
Let's say you've got 2 minutes for this question, and then we'll do some change.
Okay, cool. So
Sorry.
yes, 100%. So my belief is that the roles of BA and QA are going to be effectively redundant, and that engineers and PMs are going to start merging like the substance into each other, and that engineers are going to have to start to learn to do this really shocking, terrible, scary thing called talk to customers. And we're going to have to actually start getting involved much earlier in the process. Yeah, forward deployed engineers, the $1 million job title. Okay, so I'll just cover change fatigue then. So an interesting bottleneck that's outside of everything I've just talked about is your customers. And change fatigue is real. I've experienced it myself where I've logged into an app once a week, and every time I've logged in, the whole UI has changed. And I've just looked at that and gone, I don't want to have to learn how to use your thing again. I just want to use your thing to do the thing I want to use it for. And change fatigue is this fatigue from things changing. So one of the interesting solutions to that is to actually batch visual changes, basically go back to waterfall from a UI point of view, and big batch releases where we basically deploy it into prod behind a feature flag, and then every month or two turn a whole bunch of feature flags on in one go, so that it's all in prod, it's all been tested, it's all worked, close inner circle users. But to reduce people's change fatigue, we just, it's a bit like going down the bank of physical switches and going and just turn a whole load of things on at once. So rather than getting this slow drip of features, you just get a whole load every couple of months. I thought that was just a really interesting idea to deal with the fact that we can change things so quickly. Cool. All right. Thank you very much.
Thank you.
Thank you all for coming. My name is Marcelo. I am an engineer at ANZ. I'm going to be talking about dogged execution with a Swift temporal SDK. Let's go. This is my dog.
Senna.
Yeah, his name is Senna. And I really, really like my dog. And I think everything is better as a dog. I think everything is better as a dog. Yes, I didn't write this wrong. Like these guys, they would be so much better like this, right? Like this guy, like this. Like that's what I want. That's what I want. So I made an app. All right? The app is called Better as Dog. Yeah? So here's how it goes. It fetches an image from the internet, I enter an URL. It retrieves the faces. You get it? Fetch, retrieve. Yeah. Retrieves faces.
Were you waiting for applause?
Thank you. Somebody gets it. And then it dogs the image, right? But what if the network gets shut off, yeah? Yeah, what if the face recognition goes on a mud swim, or the whole thing gets buried somewhere? What if? Like, then I have to think about more stuff, right? Like, why my fetch image needs a retry scheme. My retrieve faces. I knew I was going to say that. All right. I got breathe. My retrieve faces needs a retry scheme. My dog image needs a retry scheme. Everything needs to keep your state. And what happens if a retry scheme ends up downloading two of the same image? What happens on the workflow when it goes forward? Does it send both images in one of them, the first one? So we don't know. So a simple three-state workflow became a pretty average complicated state machine, right? So what we need is durable execution. And guess what? Temporal is a durable execution platform. Its durable execution guarantees that the application will run all the way to completion. Okay? Let's talk more about it. It allows developers to focus on the business logic while temporal handles the catastrophes. Okay? So temporal applications are basically workflows. And some examples of workflows are like booking holidays, filling expenses, transferring money, or putting dog on faces. Yeah, workflows are you guys love it. Workflows are deterministic, which means that for the same input, deterministic is key here, because for the same input, we're going to have the same steps all the way to the conclusion. And workflows, they orchestrate activities, which is another concept of temporal. What are activities? Like fetch an image, that's one we have here, is an activity. Make a payment, send an email, book a hotel, book a flight, send an SMS. Those are all things that belong as part as a workflow that workflow orchestrates in order to achieve the completion of the system, right? And activities, this is important as well. Activities are, and I'm sure I'm going to pronounce this wrong, idempotent. Yeah? Score.
Better than faces.
Yeah. Redemption. So being idempotent is, this is key here as well. It means that if you repeat the same task, you're not going to have the output duplicated. It means that if you have a task that says it's a payment and you repeat it, the payment's not going to be made twice. Okay. Now, there are workers in temporal as well, and workers, they execute the workflows and the activities. There's a temporal service that oversees the whole execution, and there's a client that can start and query workflows. And this is roughly what it looks like, put it all together. We have a client that interfaces with the temporal service. Temporal services, they have a worker connected to it, and the workers kind of get told, or they poke on the service to be told, if there's anything waiting to be executed in the queue. And then from that, they can dispatch workflows or activities coming from that. Okay. There's also temporal UI. And the temporal UI is a website that they have available, which is basically a client as well, that you can look around and see how your workflows are doing, what's happening, what repetitions are being done, what dropped, when stuff finished, when stuff stopped, your queues. It's very thorough. Now we talked about the Swift Temporal SDK, and the temporal is made to be used through many different SDKs. Most famous are Go, Python, Java, but now we have the Swift Temporal SDK that came out a couple of months ago. And about the Swift Temporal SDK is that it provides the client and the worker for your application to run from, but deep in the core of it, it uses the Temporal Core SDK, which is built in Rust, and with that it uses the FFI bridge with the C interlop to interface between the Swift code and the Rust code. And interesting as well, we have the gRPC Swift layer, which means that you can reuse all the configurations for gRPC Swift that you have already to get the Swift Temporal SDK connected to the temporal service. Let's take a look at Better as Dog. And it's a Mac app that I got it running here. Before I do that, I actually have to start my temporal service. Temporal offers, they have a CLI, because everything has a CLI these days. And they offer a local version of the server that can run locally for your own development. They have Temporal Cloud, which is a temporal service that you can subscribe to, but is an open source platform that you can deploy in your own infrastructure if you want to. Temporal Serve, this is for me to run locally, and I believe it was ServeDev. There you go. Now we have a little temporal service running in memory in my computer. And here is Better as Dog, which I'm going to run. And now we pray for the demo gods to assist me in this time of need. And there you are. Thank you, but you will clap so much later. So it's a very simple interface. We have an image URL, you input the URL, you press dog it, and then it's going to show the image that has been dogged underneath. Let's take a look at the interface. Let's take a look at the code. We have here a dog service, right? And let me close this. Is it big enough? Yep. Our dog service, we do a couple of things. We create our worker, and we configure our worker with our activities and our workflow. We have a client. We create our client, and we run them all, right? Here you're going to see that I'm configuring my workflow with connecting to my local computer using plain text, not cryptographing to my own computer. And I'm establishing that there's a task queue called Better as Dog, which is where we're going to be running. Also, we have here in the client, like I said before, our client is responsible for telling our service what wants to be done, and the service will the workers will poke the service to let know what kind of work is being done. So in this case here, our client is going to be starting, when we call this function, our client is going to be starting our dog workflow, sending an URL, and that's going to start all the process. Our workflow is here, and our workflow is very simple. And you can see that we codify this in very procedural Swift code. I have 3 activities. The first one is about fetching the image, which is going to return me an image URL, a dogless image URL. The second one is a retrieve faces. It's going to return me the faces. And to this, I'm going to be sending the dogless image that I received on the first step. The third step is the dog image, which I'm going to be sending in the dogless image URL. The faces is going to be returning the dogged image URL, and it's going to return it. the activity, by the way, that URL is a place in my local file system where I'm saving the files as it goes. It's important that everything in between the steps in temporal is codable. And because everything goes to temporal server, there is a limit on the amount of data you can send through. So if I wanted to send the whole data of the images, that could work as long as the images were small enough, but I would be hitting the barrier pretty quickly with images. It is codable and possible though. So my activities, I download my first one is the fetch, which is pretty simple. I just download the image and I save it locally. And here return the URL. It's how you write a function if you write in the workflow directly in your computer without using temporal. The retrieve faces receives an URL. It uses the Apple Vision framework to look for the faces in the image, and it returns rectangles containing the bounding box of relative to the edges of the image on where they are. Okay. The last one is the dog image function that it receives the image URL and the faces, and then it composes an image by getting my dog face and printing first the base image, the dogless image, and then going through each of the rectangles that got found and putting the proper dog face on it. And then it converts to bitmap and then saves it locally, and that's it. Let's see it working. Did I miss anything? No. So, of course, I forgot to open something. Let me open this one and close my other notes before you guys start reading them. Okay, let's get this one. Let's dog it. There you go. Pretty good. Let's try more. More. Thank you. Thank you. More. It's good, isn't it? There you go. Who is the good boy? The Vision framework is amazing. More. There you go. More. This is going to change the way you watch TV forever. Look. And last one. There you go. This is fantastic. Anybody want any images to test?
Center on center.
Anybody else wants? Because it needs an URL.
Yeah, it returns one.
What do you think about progression now? I thought it was easy.
I'm going to Google you. I'm going to put your... All right, if nobody has any sane requests. And, oh, of course, there's more. I'm going to open here and show the temporal UI to see what happened. So the server is running locally, right? And these are the workflows for the images that I just ran. If I open one of them, you'll see here that it happens exactly what we were expecting. We had a timeline. This is the workflow from end to end, and then this is the first activity that happened, which is the fetch image. After that happened, the next one came in, just retrieve faces, and the last one, dog image. And if you click it through, you can see exactly what the input was, which is the file saved on my file system, and what the output was, which is the faces that were found in the image. One last thing that we can look into, and that will show where the value of temporal actually is suppose that you were trying to load something and the something is not found, or the network goes down, or the warehouse where the server goes catches fire or something happens, right? Let's just create something here. Yep. So this is not loading. Let's see in temporal what temporal is doing. See, it's still running. It's trying, but what is it doing? It's trying to fetch the image again. It's getting 4 of 4s. It's trying again and again and again and again, and it goes according to how I configure it. I can configure a maximum number of repeats. I can configure it with a timeout. I can configure with some escape routes. It's very versatile like that. And if I cancel it, if I go back here, you can see that my worker got told that its work was canceled. So the application resumed to where it was before. And that was Better as Dog, which $199. And I hope you appreciate it. I hope you guys got a better idea on what temporal does, and I hope you can find workflows that can help, that you can use it to help in your day-to-day. Anybody has any questions?
Thank you. You mentioned that it's durable executions.
Yeah.
The first flow which I seen, that's a remote server. Which
Pretty what?
remote server where this temporal is running. Like you have a client and server is somewhere there.
Yeah.
So how client will be guaranteed to have durable state when you're losing connection time to time?
Yeah. So the server keeps the state, not the client, right? The moment that a client drops down, sorry, the moment that there's a client and there's a worker. The moment that a worker drops down, right, it's not pulling 4 jobs anymore. And the server knows that it's not completing the execution because it keeps on sending back information as it goes. It can send, say, heartbeats. It can send, say, completion points. The moment that the worker comes back up, it will ping the server and tell the server, look, I'm back up. Do you have anything to do in this task queue that I can execute? And then the server is going to tell him, yes, do this specific activity with this specific input and this specific output, and give me the output for it when it comes back. So that way, now think about it in a broader context. Like you could have a farm of different workers, right? And a worker executing something drops down, right? So for some reason, the Kubernetes cluster, whatever, dropped. Like there's going to be another worker somewhere in another farm, another AWS entity, whatever, that can follow the same task queue, and it will be able to get that job and execute the job instead of the previous worker. Does that answer the question that you were alluding to? Yeah.
So basically, if you fail to send your request, that's done. You don't have durability.
You have to somehow get the server to know that something has to be done, but the server keeps the state. After you tell the server that's supposed to be done, it's the server's job. The client can query it. The query can know what state it is in, but the responsibility belongs to the server.
So server is durable, application is not.
Yeah, it's an orchestrator, right? It keeps the state, and it makes sure that everybody that can do the job does it.
Good to see it as a worked example. What I'm wondering is, like, for a mobile app, what would be any advantage of having the mobile app act as a worker, as opposed to you send a traditional API request to a server, the server then goes to temporal, and other servers pick it up?
That's a very good question. I'm pushing the bar with Better as Dog. You could possibly get clients, the mobile app to be clients, and have workers working on other platforms, and the client can get the results of the workflows that are executed. Does it make sense? Yeah, but getting the application itself to work As workers themselves, I'm not sure I can think of any use case like that right now.
The workflow that can be controlled by the server. So, like, could I potentially say your example required the output of one job to go into the next
Yep.
job, but say that
Yep.
they were, completely isolated. They didn't need the outputs. Like
Yep.
there were 3 disparate
Yep.
tasks. The order, could that be controlled by the server?
It's controlled by the worker.
Controlled by the worker. So that would have to be compiled into the client. My thinking is if
don't have to be the same code. They can be separate code.
my thinking is that my wife uses a system for her. She's a freelance makeup artist, and she has like quite a few workflows for her clients to go through.
Yep.
And if I was to like build an application, but she wants to like rearrange the workflows all the time, it's like, well, I don't want to be constantly rebuilding the client or the applications every time she rearranges the workflow.
Mhm.
But could I build a system like on the web and server side where she rearranges the workflows and all those tasks just trickle down to the client?
You can have different triggers for different works, for different activities within the same workflow. So you can have all activities really waiting for some sort of input, and you can start a single activity that would trigger a sequence of other activities as well coming from that activity. Or you can have separate workflows as well, if that makes sense as well. So you can architect in different ways.
A comparison that people here might be used to is something like GitHub Actions, where your workflow is defined in YAML. In temporal, your workflow is defined in code. In this case, Swift code, which means it's Swift code. You can put whatever conditionals in there you want, and in third-party inputs that you want in there, whatever it is, it's just code. And that's what makes it so good. You can change halfway through a workflow, you can redeploy your code, and the code has changed and the workflow will behave differently.
It's built in a way, it's workflow as a code, right? So it's built in a way where the limit is the limit that the language provides you right now. And these days we have Swift concurrency, and it fully digs into Swift concurrency. So if you do like an await state that doesn't stop the execution of the workflow, that means to temporal that the next steps in the workflow are available as well. So you can start different activities in parallel like that, because Swift allows it to. So I think the answer to your question is that if you can code what your partner wants to do in Swift, you can probably code it in temporal as well. Kira?
I'm kind of building on kind of what Amy was talking about. I think so. What I'm getting here is that if you've got a temporal workflow, now your iPhone clients can participate in that work. Right, so I think what we'd like to see from you is to code up a demo where we have, multiple iPhones doing some work using the very good CPUs that they've got and GPUs and neural engines and all of that, and going up to the server and getting some work done all the way through. Is that even possible?
Actually. Yeah, there was a project we worked back in the day about figuring out genome structure for cancer research, and that was distributed just like that. I think temporal could have been used for the kind of project.
I think Kira is planning her next Bitcoin operation.
Or that, yes.
That's the way.
Thank you.
Thanks everyone for joining. The last bit to remind you about the social events that are happening. That is next Wednesday, Coding Night, here at Mantel Group. And the Wednesday after that, there's going to be a social night at the Precinct Hotel, and that is the night before Dev World. Thank you so much for our sponsors, Mantel Group and RAE Group. And let's go and socialize at the Mitra Tavern.